So, are we ready? Well, I think so. So, hello to everyone. You know my name, it's Daniel Starnowski. I came from Poland here. And I would like to say a few things about IPv6. Not just the IPv6 protocol, but implementing it on Mikrotiks. But at first, I need a question. How many of you heard about IPv6 and saw how IPv6 address looks like? Okay, and how many of you have already configured even one IP address on your router? No one? Okay, 2 people. So I don't need you to change to any other audience because all I need is you. Because this course is meant to, well, not overcoming fear of IPv6, but becoming familiar with IPv6 concept and configuring IPv6 on Mikrotik routers and so on. Because I realized that when I didn't do that, before I was just uncomfortable with the IPv6 address because it's just large and I don't know what to do with that. But after I configured it once, it became clear, just a normal address. So this course is meant to provide basic hands-on knowledge and configuration knowledge about IPv6 addresses on Mikrotik RouterOS. This is not meant for people who already have experience with IPv6 addressing. So what I will talk about is how just a simple IP address looks like, IPv6 address, and how on Mikrotik routers we assigned these addresses to interfaces, how we add static routes, and what changed in IPv6 compared to the IPv4. It would be just some practical knowledge, not exact, looking at the IPv6 frames, looking at each field of the frame, what changed, and so on. And we will say a few things about stateless auto-configuration, so how to connect our laptop computer to IPv6 network, because it's more easy than with IPv4, I think. And we will try to configure simple OSPF version 3 just to have IPv6 routing. And if we have still time, we can see how DNS records for IPv6 addresses look like, and what are link local addresses, because it's also a nice feature with IPv6 networking. So we will start with preparation for the lab, because I think most of us have latest stable version of Mikrotik, but I think by default we have disabled IPv6 networking. So all I need you to do is to enable IPv6 package on your network routers. Okay?
I have heard that IPv6 support is added in version 5.
No, you heard it wrong.
Okay, full support or complete support.
Yes, but we are looking for support of forwarding and routing IPv6 packets, not using IPv6 to log into your router or to open.
So the best thing to do with the version 6 is to upgrade, yes?
With version what?
With IPv6 addresses. Would it be to get version 5?
Well, we don't need that.
But
we just use the features included
at home
in...
I should upgrade if I go to IPv6.
Sorry?
At home, what should I do at home? Stay with version 4 or 5?
At home, you can decide. Because version 4 is all you need to forward IPv6 packets. Version 5 includes some nice tools, for example. Many tools that operate on IP layer are also included in IPv6, for example, bandwidth test, torch, and so on. You can log you can log with FTP or Telnet, or I think SSH also with IPv6, and so on. These are that kind of tools. But you can configure IPv6 networking to forward packets from your network to the internet and backwards just by using the latest stable version. So it means 4.17. So I don't need you to upgrade. If you have version 5, it's okay. If you have version 4, it's okay. Just enable IPv6 package. So you go to the system menu and packages. You highlight IPv6 and click enable. So I think almost every of you have ever enabled or disabled packages, so you know how to do this. And does anyone have some problem with that? It is clear for everyone how to enable IPv6 package on our Mikrotik? It's okay. Okay, so after we do this, we will configure the lab. If someone wants to, he can reset his router for the IP package to be included. But we will reset, or maybe, okay. So maybe after doing that, you should also reset configuration of your router, just as in the beginning of every lab in this class. So please do the full system reset and reboot your router to the IPv6 package be turned on. So just enabling IPv6 package and resetting configuration. Everything is okay for everyone? Okay, so now, not to distract during the lab, we will prepare the simple configuration of the lab. I have my access point right here, and I need all of you to connect to this access point, but only on the second layer, only wireless data link connection without, without any IP address. Sorry?
Which band? 5.2?
Yes, so this is the configuration of wireless. So this is wireless connection to my access point. I would like you to use band 5 GHz, and my SSID is lab. And I would like also to ask you to change your radio name to number, underline, and your name. And number is your hexadecimal number of your position in the class. So, as in the beginning of every class, we will assign numbers. So you are number 1, number 2, 3, number 4, 5. Okay, so we will skip number 2 and number 1, number 3, number 4, number 5, 6, 7, 8, number 9, number 10, so you are A, number 11, so you are B, and number 12, so you are C, hexadecimally. All of you know the concept of hexadecimal digits, and 10, 11, 12 is ABC, right? So you are A, you are Arne, you are B, and you are C.
So 255 please.
Sorry?
How much is 255?
FF. This is the maximum number you can reach with 2 digits, hexadecimal. So I think all of you know how to connect to the access point. You just open wireless menu, open your wireless card, enable if it is disabled, change band to 5 GHz and set SSID to lab. And also you need to go to advanced mode instead of simple mode and change your radio name to your number, underline your name. Now we can see how we are connecting the access point. Okay. Some of you have already connected. We will just wait for the others, not to distract during the rest of the lab. The configuration once again is 5 GHz, SSID is lab. And you should change your radio name to your number, underline your name. So, any problems so far? Any questions? Any doubts? Okay, so we will just wait for everyone to connect. I shall get some bottle of water. Excuse me. So I must tell you that now, after 10 minutes of talking, I understood why Yanis drinks so much water, because my throat is going dry.
It's not talking, it's conditioning system.
It's very dry area.
Maybe, but my throat is not going to make it till the end.
Change
It
your
will.
packet.
Don't worry.
Sorry?
Change your packet and keep.
Yeah, I would. So I think we are waiting for number 8.
So who is number 10? Shouldn't be.
Sorry?
There should be no number 10.
Yeah, number A. You should be number A. Are you connected to the access point?
Oh.
Yeah. You should change to A, to hexadecimal. Just because we will use those hexadecimal digits in our IP version 6 addresses. So you are A. Did you change to A? Your name? What is your radio name? Okay, what is your radio name? Yeah, exactly. So now, about IP version 6 addresses. This is the example IP version 6 address. It has 8 blocks, and in each block we have 4 hexadecimal digits. So we have, very many possibilities. These are 128 bits, so this is 4 times bigger than simple IP version 4 address. And it is always divided into 2 parts. The first 4 blocks is the subnet part of the address, and the rest 4 blocks is the host part. So, for example, this is example of IP version 6 subnet with /64 mask. /64 means that the first 4 blocks, means 64 bits, are subnet, and the rest, of course, is host. Always the latest 4 blocks is the host block. And we never divide IP version 6 address to more exact prefixes than /64. We don't have /7, please.
What in case of point-to-point tunnels?
Oh, we also add. Well, I think we use 64, but let me check it after we finish the class. Okay. So the concept is that we always assign /64 to our subnets.
Like /24.
Sorry?
64 is like 24, like
No, but
counted class.
yeah, it's something like a usual class, but for example, in my network I have more than 500 customers in one subnet, connected by just switches, layer 2. So I need to have /22 network mask. But I don't use /22 network mask to connect 15 clients to my network, because this is wasting of IP addresses. With IP version 6, we always use the /64
Can I
part.
summarize that?
Yeah.
In RFC, there are recommendations that customer is represented by /64. One customer is /64. So one.
It's like /32.
No, this is...
It's
Okay, we will see it in next slides, because I have prepared comparison with IP version 4.
That's if you follow the recommendations of RFC.
So these are just examples of the mask. But when you add IP address to interface, you always add the 64 mask. These are used for routing, just to see that 16 bits is the first 4-digit block, 32 digits are the first 2 blocks, and so on. So how do we write IP version 6 address? We already told that these are 8 blocks of 4 hexadecimal digits. But for example, we often have the few blocks of zeros. So some wise people came to the idea that we don't need to write down all those digits because we just need some of them. So at first we cut the leading zeros of each block. For example, instead of 0, 4, 6, 8, we write 4, 6, 8. We cut the 0 in the beginning. Instead of 0, 0, 4, 0, we write just 4, 0. Without the leading zeros, because it will be the same. This is the same hexadecimal number, 468 hexadecimally. And after we do this, we can also cut whole zeros group into nothing, just leaving 2 columns. So if there is one or few blocks of zeros, we can cut them just to double column. Is it clear for everyone?
Can we do that more than once?
How we do that? Just wait a minute. Is that clear for everyone?
Yeah.
You're not in the class. So this is the example. The base, the IP version 6 address we started from, and the IP version 6 address we came up after cutting those zeros. Cutting this 0, these 2 zeros, and grouping that zeros into double column. Is it clear?
Yeah.
Yeah. So, an example. Here we have a good example of IP version 6. Oh, sorry. Okay. I will correct it later because I corrected it by it didn't save. There shouldn't be that 0. But okay. This is good IP version 6 address still. And this is bad IP version 6 address. Why?
Because you have got twice 0 groups.
Yeah,
you
but
only, you can cut 2 times the 0 groups.
why? Yeah.
Because it's impossible to understand how many zeros is collapsed.
Yeah. Exactly. You all understand what Mikhail said? When we have 2 double columns, we don't know how many zeros are here and how many zeros are there. How many 0 blocks. So we can cut the 0 blocks to double column just once. Yes?
Do you always need to write the 2 first and the 2 last octets as it is? You can't use this double columns for the last one and the first
Yes,
one?
you can.
You can?
Yes.
Okay.
If you write down, you will see, you will configure it, so don't worry.
So
Now we start. Yes?
and when some kind of this IP address appears, we cut the first one of the right or on the left group. If you want to cut we have
2 groups of zeros.
2 groups of zeros, we cut.
Yeah, we can choose. So we have, for example,
But we choose the right group or the left group.
we choose what we want. So if you have, for example, 0, 0, 0, 0, 0. Oh, 0, 0, 0, 0. Da, da, da. A, B. Okay. 1, 2, 3, 4, 5, 6, 7, 8 blocks. So we can cut this block into 1, 2, 3, 4. Double colon and the rest. But writing those zeros with dot 0, colon 0, colon 0, colon A, colon B. You can't cut those if you cut that one. But you can also cut those and write this one.
That will be easier.
Yeah, that will be easier because we cut 2 blocks instead of 1. So that's why you can choose. And the first and the second version is clear because it's one exact IPv6 address understandable by every human or machine. So it doesn't matter which version we choose, which block of zeros we cut. It's just for us to be simpler. So in this example, we cut this block. We leave those zeros as a single zero in the block, then write down the rest, then cut this block of zeros and the rest of IP address. Right? It's clear for everyone. Okay. So now we will try to configure our first IPv6 address on the internet, on the interface. So this is our lab example. This is my access point. It has already configured IP address. Does anyone have an idea why I choose such complicated IPv6 address, not just 1:1:1:1 something? Why is it so complicated?
You want to confuse us?
No. Yes?
Maybe it's reserved for some purposes.
No. Actually, I didn't choose that. I received it because it's actually, these are global IPv6 address with connection to the internet. I am already connected to the internet with IPv6 tunnel. So if you manage to configure these IP addresses, you will also have IPv6 connection to the internet. So we start by configuring our addresses on wireless interface.
Excuse me.
Yes?
I already have some addresses, about 4 addresses on each interface.
Yeah, you already have some dynamic addresses. We will talk about it in the end of the class. We have as many dynamic addresses, as many interfaces we have enabled. But these are dynamic addresses, and let's just talk about these in the end of the class. These are dynamic addresses. Well, we can say that, do you know the group of IPv4 addresses 169.254?
Yeah, that's unassigned or invalid.
Sorry?
When you don't have assigned anything, you,
Yes,
you see this.
Yes, when you don't have any IP address assigned, you can sometimes see this. On Linux, you don't see this.
You know why?
We-
Because these addresses are private addresses for Microsoft.
Yeah, but this is my...
So when they
Microsoft.
factory testing their dhcp server, it automatically gets the addresses from that range.
Well, but these addresses are reserved also with...
for Microsoft.
Is this an
It's Microsoft.
Is this an RFC 1918 range as well?
19.
RFC 1918,
No,
which is regulating the private IP addresses?
no, it's not.
It's a
So-
Microsoft
So the,
IP address. It's not proprietary. It's
yes, but
proprietary.
this is such concept of Microsoft, but in IPv6 address, also wise people came to the idea that this is actually a good idea. If you don't have any server on the network, just two computers connected, why wouldn't they have address? So each IPv6 host has dynamic address from the group of FE80 : something something, and these addresses can be used to communicate with the devices. And this is standardized already.
So who did assign these addresses?
Sorry?
Who assigned these addresses to my interfaces?
These addresses are assigned basing on your interface MAC address, or interface address.
So RouterOS computes them?
Yes, RouterOS computes them. We will see it later. Just give me some time, you will see everything. Now I would like you to assign IPv6 address to our wireless interface. So if all of you enabled IPv6 networking on RouterOS, you should see the IPv6 menu on the left side with Windows. So we just go to IPv6 menu, click address, and we just add address. These addresses are dynamic and we do nothing with them, we just add our static address. So the address would be as follows with your number as n. So for example, you would be 2001:470:28:762:4/64/7.
What is the EUI 64?
EUI is, just as Arne said, the dynamically computed MAC address of the interface put as the host part of the IPv6 address. We don't want it because we configure our IPv6 address manually, so we don't check this EUI.
Should be assigned as network portion.
It would be, excuse me?
Should be assigned the MAC address as network portion,
As the host portion.
host portion.
As you see with this address, here is the subnet part. The first 4 block is the subnet. This is the block I received from network. And other 4 blocks are just block of zeros, block of zeros, block of zeros, and the last one is our number. The simplest we can get.
So what about these advertised blocks? Is it some kind of propagation of addresses or?
We leave it for now, we will talk about it also later.
Okay.
Okay, so have everyone configured IPv6 address with that standard on wireless interface? So now I want you to check IPv6 connectivity and ping the gateway, which is my access point. In order to do that, we use the simple ping. We go to Tools menu, ping, and instead of normal old IPv4 address, we write IPv6 address, which is the address of my access point. So if you are successful, you should have response from my access point. Is it going all right? Yes. It's going. Oh, beautiful. I see that everyone is now pinging my gateway.
I'm not.
You're not. Double colon F. You should ping double colon F. Here. Before F, you have double colon. Okay, so now ping it. Time out. You have. What interface you assign your address to? Is this the same address? 762 2001, not 2010. Just a digit mistake. Is it right now? Yeah. So everyone has IPv6 connectivity. Let's go on. Here are some IPv6 ranges already reserved. Well, this is the division of all IPv6 addressing space into smaller blocks. Almost every of them are reserved, there are just some used. The most interesting one, of course, is 2000:3. So these are addresses, all addresses starting from 2000 and ending on 3FFF and blah blah blah. /3 group of addresses. These are addresses used in the internet. It's just like we took all IPv4 space, but exclude the private addresses 10. Blah blah blah, 172.16 blah 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 with mask, and so on. And those multicast addresses and so on, we just receive usable in internet IPv4 addresses. So this group is corresponding to them IPv6 addresses that can be used in internet. They can be assigned by RIPE or ARIN or other organization assigning IPv6 addresses. And we also have some special addresses like this FE80 double colon blah blah blah, which are dynamic addresses, like we saw. They are called link local unicast. Link local addresses are those dynamic addresses we already saw with on our interfaces. So now, having this, if we would like to get internet access, sorry.
It's about asking about the global unicast. You say it should be started with 2000, right? 230.
No, it's 230 with mask
Okay,
3.
because
it's
see here that after we assigned the 201.
yes, because it's
here
mask.
the G flag is mean global.
Yes, but wait. We have no paper.
Other way around.
Sorry?
List that.
Ah, okay, sorry. I'm not used to this kind of. So 2000 double colon mask 3 means 2 is binary 0010. This 0 is 0. This is 10. This is here. And so on. So the mask 3 means we have 3 bits constant, these. So when we change the other ones, it's 0, 0, 1, 1, 1, 1, and so on. So here is 3, here is F, here is F, and so on. So this is the whole range of addresses starting from 20 ending in this. So our address 2001 is one of the global addresses, which will be routed in internet and so on.
You mean the first digit number, the 2 is unchangeable, we cannot change, but 30 is possible to change.
You can change the 2 to 3 because it's binary.
Yes.
You can't change first 3 binary digits. You can change the rest 125. So they are F. So this is the whole range of IPv6 addresses. So now, if we configure default route to the internet with IPv4, we always get this 0000/0. Yes?
Is the ID behind this address stream that the authorities will release blocks later on when the need arises? Or what's the, you know, the philosophy behind this stream?
The philosophy behind this reserving, I don't know the exact philosophy, but they can be released. They are reserved for future uses.
Yeah.
So you don't know what these future uses can be. They are just reserved because this /3 is enough to give everyone a global unicast IP addresses. But IETF can release the addresses, give them to Jana, Raik, Arin, and so on.
One of the developers of IPv6 said that next address range /3 that will be released will be for the next planet.
Yeah, well, that's a good idea. So now we will add default. Oh, yes, please, right?
Not about this.
Yes.
I have a question about what about address resolution? What would be ARP for IP version 4? How does it work?
Yes, as I stated in the beginning, in the overview, if we manage to keep time, if we still have time in the end, we will talk about IPv6 resolution with DNS. So now just move on. We just have to add default route to our IPv6 routing table. This is as simple as IPv4. We need just to go to IPv6 menu, click routes.
Menu.
Sorry?
Menu. Many is more than few.
Menu.
Menu.
Oh, thanks. Whole life I was talking many.
Many is more than few. There will be
Well,
many participants. In the
Thanks very much. I use English for many years. I've been abroad a few times. This is the first time someone said me I'm, you know.
And you know what curse is?
Yeah.
It's not good. Worse than course.
Exactly.
Yeah, when I was a child, I learned to read delayed. When I had my computer, I always read delayed. And for over half of my life, I was saying delayed, until someone said me, it's delete, not delayed. So, okay, menu.
I just found something else that Mikrotik have English classes too.
Yeah, we have some
That would be
students
good.
who come from England, and then there is characters and all the other things are eliminated.
Okay, we just need to enter IPv6 menu, root, add new root, and set the destination address to 2000:3. And this is the example, as you asked, of using double colon in the end. We don't need the 0 in the end. This is clear. Everything after that 2000 are zeros. We don't need to add the digit in the end of the network address. And prefix is /3.
So it's 230. Colon slash 3. It means default gateway like 000.0.
Yes, this
It's
is
whole subnet, whole IP address.
global IPv6 address, reachable in the internet for now. Yes?
Could you apply even a wider route, which also includes all these reserved blocks?
Yes, you
Even
could.
though it doesn't make any sense?
Yes, you could. It would make sense because these are not used, so you will have connectivity to them. But we will just do it this way. Later, as we see with OSPF, OSPF treats default root as 00/0, so we will see it later. Now I want everyone to... did anyone have any problems with the default gateway? No one? So now we can check if we are connected to the internet. Just by using simple traceroute, tools traceroute, but instead of IP version 4 address, we add IPv6 address to traceroute. And we will check if it connects to internet.
So where is this gateway address applied? Is it on your router or is it somewhere?
This gateway number is what you pinged before. This is the address you
Right here.
put ping. This is
Yeah, I see.
my gateway. This is the $F address.
Good.
And this is your gateway to the internet with IPv6 addresses.
So what is the IP located? What are we trying to trace?
So this IP is ipv6.google.com. This is Google.com, which only has IPv6 address. It doesn't have IPv4 address. Well, the DNS name is only resulted in IPv6. I tried to ping Mikrotik.com because it also resolutes to IPv6 address, but it doesn't respond to ping, so sorry, Yanis. We are trying to trace ipv6.google.com, which address in IPv6 is 2800:145.0, and as you see. So, does it go? Okay? Okay? Yes? Oh, it is a... I think you don't have the good IP route. Could you show me your IP route? IP route. IP version IPv6 routes. Routes.
You know, sometimes you need to
This is reachable.
it's enabled.
Okay, so what do you try to make?
For what I want to say, I think it's just making
Can I start? Just give me 1 minute. Some technical problems. Strange. This is really strange. What IP address you have from this? This is your address.
No, you must put 6. That's 6. Maybe mistake with another
my mistakes.
Okay.
I'm 6, not 7.
Okay.
Mistakes.
I'm sorry.
Yeah, try it now.
I'm sorry, sorry.
So try it now. Yeah,
Sorry.
okay.
Sorry.
Is it good for you?
Yes.
Also? Everyone can see this whole trace list, and in the end, the ipv6.google.com host. Yes?
I'm asking that because this subject is interested. I'm not trying to kill your time. The question that I know some of router in between when we try to trace should support the IP version 6 for routing. So I want to ask you, did you make some tunnel to your ISP?
Yes, I need to make a tunnel. At first to my company just to have public IP version 4 address here. And then with the public IP version 4 address I have tunnel broker. Have you heard about tunnel broker?
No.
It's the website where you can get for free IP version 6 tunnel. So you connect with IP version 4, there is a special, on Mikrotik there is special interface. In the interfaces menu, you have 624 tunnel. This is a special kind of tunnel, 624, that, well, you just put, I can show you my tunnel. This is 624 tunnel. From my IP address to the tunnel one of tunnel broker servers. And through that tunnel, through IP version 4 connectivity, there are IP version 6 packets going. So you can register for free or on tunnel broker, you can get 5 tunnels for free. And on that tunnels you can get /48 networks just to distribute by yourself to test connectivity.
Have you another possibility for this only to go to this site that you say? Or IPv6 tunnels?
Are they usually?
Are usually they get, yes.
Yes,
You need to request them from them.
yeah. Higher tier providers must provide IP version 6 because IP version 4 basically run out. The highest instance already gave out all the addresses to the lower instances.
Last month.
Yeah, so last few months, and if you will request new addresses in the end of, I would say, June, you will not get IP version 4 new addresses. So IP version 6 is here.
But, I don't know if it is in the whole world, but in Europe, RIPE allowed to sell IP version 4 address pools. So you can sell, you have IP version 4 pool with /22, for example, or /20, and you don't need so much because you have /17 also. You can sell those /20 to other company, with usual stock prices.
Imagine what will happen to the full BGP feed.
Yeah, I imagine. Yes, yeah, you wanted to ask something?
Yes, what's the schedule of implementing IP version 6 in everyday life, homes and...
Well, there is no such schedule. It will be just,
Suggestion
Sorry?
Some suggestion for the start to use IPv6 in the
well, on June, we will have a World IP version 6 Day. So many companies will try to do, funny, exciting things with IP version 6. I can't remember exact the date. I will check about when we finish the lab. But it's this June. This is the first World IP version 6 Day. Just to have the beginning. But for a long time, I think few years, it will be the crossing with IP version 4. So we will have IP version 4 and IP version 6 connectivity at the same time. So-called dual stack.
All devices made after year 2000 need to have at least rudimentary IP version 6 support. That's the standard. So what's the plan? Plan is already implemented, it's going on, and it's close to finish.
Yes, but no one can predict when the last IP version 4 address will be deleted from the last interface. You can't predict it.
but the scenario will not be that IP version 6 externally, and then we use our own devices native on IP version 4 inside.
Well, every
inside.
device will implement IP version 6. Already does.
Yes,
But it's just a matter of time. We will see. It will be a few years, and during that few years we'll probably use both IP version 6 and IP version 4. But more websites, more servers will use IP version 6 instead of IP version 4, and IP version 4 should slowly, fade out.
I think the actual question is, can you not IP version 4 to IP version 6? No. Those are different protocols. It's the same like you can't not TCP to UDP.
Okay.
So
what do you do with your own home routers and computers and?
if they are made after year 2000, they should have support.
Well, computers, I think it's
All
just...
computers, all operating systems starting from XP.
Yeah, but it depends on operating system, basically.
So
This is probably maybe some own device.
What about small
All
routers?
devices.
I read somewhere that already this year they're going to start ship units that support only IP version 6.
yeah, that's the actual question. Now they support both
But
from year 2000 upwards, but afterwards they will support only IP version 6. And by the way, in IP version 6 there's no NAT at all.
So I can tell you one interesting thing. In about 15 minutes, Yanis will break this presentation. So if we can two ways. We can simply discuss about IP version 6, or we can configure IP version 6 on our computers to see how our computers connect to the IP version 6 network. So
Let's do it.
okay, let's do it. As you said, we all saw that our routers are connected to the internet with IP version 6. This is the old IP version 4 concept. For example, we have the routed network of something /24, and 24 is not too much, not too many addresses. So we divide them and we connect the devices with just connectivity pools of /30. All subnets between two devices we have /30, as usual. And on the subnets for customers or for our devices on LANs, we have /25, /26, just to get into that /24 pool and to use the addresses, just for the pool to be sufficient. If we have more hosts, we can't assign everyone a public IP version 4 address, so we just need to have the private pool and to do network address translation and so on. In IP version 6 there is no need for that. For example, we have I think the smallest pool you can have assigned is 48.
that's
So
64K addresses.
yes, that's 64K subnets, not addresses. That's 65,000 subnets. So you don't, split it to /30 subnets to connect devices /24, 23, depending on the number of hosts in the subnet. You just divided them to /64, the whole pool with 65,000 addresses. If you need more, you just get more, get /40 something, get a routing pool. Yes?
No, it is /32, I think, as you mentioned.
So normally we use this /64. Now we should assign, and one more thing, what is stateless auto-configuration? Imagine that you have IP version 6 address assigned to your router's interface to LAN, and you have computer connected to the interface, but without IP version 6 address. How does the computer receive the IP version 6 address? What does it? Okay, please.
Yeah, well, computes by itself based on MAC address.
Yeah, but this is the last part, the host part. But there is the network part. Well, how do we do it in IP version 4?
DHCP.
Yes, dhcp. We have dhcp, and dhcp in DHCP, the host asks server to assign IP version 4 address. The server responds with actual IP version 4, with the new IP version 4 address for the host. The host thanks, DHCP offer, discover, offer, request, and so on. In IP version 6, we have stateless auto-configuration as the main way of obtaining IP version 6 address. Stateless means that we don't have server which stores the list of leases and so on. This is done just that way. The router, this is the advertisement box you asked earlier. We will see it. The router just advertises the network. So the router says, welcome to my network 2000 : something. So this is the network. And every host in that network who wants to use the stateless auto-configuration knows. So if it is the network 200 blah blah blah, and my computed host part is blah blah blah, so my global network address will be this. The subnet part connected with the host part. So it is stateless because it doesn't require the server to store list of leases and so on. It just advertises the network, and each host computes his address by himself.
But
Yes?
what if there is one spoofed MAC address? Then you have the possibility of having two identical.
Yeah. Well, basically, the host tries to discover with ICMP version 6 if there is another device with such address before assigning this address to his interface. So now, this is the rest of the example. If we have a subnet, yes, please.
So, are you saying that this stateless autonomous configuration are replacing DHCP?
Where there is also DHCP version 6.
And why do you need that then?
Sorry?
Why do you need DHCP version 6?
You don't need.
Oh, what is that? If it's not giving no values.
Well, if you want just to have a list of leases, but I don't know what for. So maybe let's leave the question till after the presentation. But there is IP version 6 DHCP, which is called DHCP version 6. Yes, Mihail?
Maybe it's necessary to give administrator more control of segment of addresses.
Yeah, it can be.
Just
But
control
that-
the IP of our network.
Yes, but to control that, you assign IP addresses to specific MAC addresses. And the same is done by the auto-configuration. You know the MAC address by looking at the IP version 6 address. So it will be almost the same.
Sometimes we don't know the IP of the host. Because first we need to know the MAC address. After I learned that this is the IP for that host, the X host.
No,
I
but
have DHCP, I can know the host one by one.
you can know that by heart, but for computer it is the same amount of of work to remember such hard address and to remember just a simple address. So this is just our human nature.
For example, if it's workstation, it's normal. When they switch network adapter, it's change my IP version 6 address.
Yes, it
But
is normal.
It's server, it's not good.
Yes.
So we need a stable IP address when I change on
Yes.
server.
Exactly. It wouldn't be good to have server, depending on your interface card. And if you change your Ethernet card, you change your MAC address and change your IP address of the server. It wouldn't be good,
This is
of course. Sorry?
This is what I mean exactly.
Yes. So now, this was the example. Just a simple look at the EUI 64. This is the host part in IP version 6 address. 4 blocks of hexadecimal digits. These are created from MAC address, but with putting this block FF:FE in the middle of MAC address, and by changing 1 bit in the beginning. I don't know why the 7th bit is changed, but it's changed. And this is the standard of EUI 64, which means extended unique identifier. This is, yes, you are laughing because you know I know.
There's a man walking on the roof. It's cleaning the...
It's always
Moving
good.
some IPv6 trying to find it.
Yeah, I can give them the presentation. They don't need you, to hide above the glass.
I asked him about the man. He was looking for IPv6.
Yeah, there is one. He's just,
Yeah,
doing the maintenance work.
Told you looking for IPv6.
1 second, please.
Yes.
I lead 2 zeros if different number 9-4, same change to 0-2 with this LE system.
No. We just changed the second bit. So if you have 9-4, it will be 9-6 in the beginning, and the rest will be the same. Because you change only the 7th bit. So it's the bit.
So the bit in the first, at the first?
Yes, the 7th bit of MAC address. So it's the
Maybe
bit.
the host portion.
Why it's changed?
Sorry?
At the host portion, 7-bit.
It's the 7th bit of this MAC address, which is located in the second hexadecimal digit in the position of decimal 2. So we change 00 to 02. We, for example, change 21 to 23.
It's my question, yes.
We change 96 to 94 because the 2 bit is swapped from 1 to 0 and so on. Well, we could write it on the board and to try to compute it, but it would take some time, which we have reserved for more funny things. So now, here we have our advanced setup. We already have configured IPv6 address to communicate with the gateway and route to communicate with the internet, and it is already going. So now all we have to do is to assign our Ethernet card, for example, Ether1 or Ether2, on our Mikrotik, IPv6 address. This is done the same way as we configured the address on the wireless interface. And the address is as follows: 2001:470:, and so on. This is the rooted IPv6 pool I received from Hammer Broker, and now it will be routed to your routers. So, please.
I looked up why that bit is 1, that previous.
Yes?
That indicates that this address is a UV64 address. If that bit is 0, then you for sure, maybe it looks same, but it's not EUV64.
Okay.
So that's the indicator that this address that will follow will be EUV64.
Okay. Yes, but I don't know why it is this bit, not other.
Because it's only one natural bit. And when you use multicast MAC addresses, you know that there is a multicast MAC address. So it eliminates 4 bits unusable, and so on.
Okay. Good. So we configure on our Ether interface the IPv6 address. This is as simple as with wireless interface, so it shouldn't take too long. And the hardest part, after we assign that, of course, instead of the :n, we put our number, so it is 1, 3, 4, up to A, B, C. And now we need to enable IPv6 on our Ethernet interface on our computer, connected to the router. So, does everyone know how to, hi Norvis, does everyone know how to enable IPv6, or does everyone know if his computer has enabled IPv6 address on the Ethernet card? So if I would like you to check your IPv6 address by just typing ipconfig or ifconfig. I don't know if you're using Linux or Windows. Just enter the command line and type ipconfig for Windows and ifconfig for Linux. Yes?
I read saying IP address on user 1.
Sorry? No, it's on the... You assign the IP address, IP version 6 address on the interface you use to connect to your router. So if you have your computer connected to Ether 1, then you assign an IP address to Ether 1. If you're connected to Ether 3, add the IP version 6 address to Ether 3. Yes. So that's perfect. This is your computer. Yes, this is CC. This is 44783C. This is exactly... Yes, and this is your IP address version 6 you can use in the internet. Yeah, exactly. So, did you receive IP version 6 address on your Ethernet interface? What is your IP config? Okay. You have IP version 6 address from your router?
I have Windows XP.
Yes, but
You have to install
the
Now we're going to install it.
there is a command. I think it's netsh/ipv6/install.
There is a button for installing the protocol.
Sorry?
There is the button in the network configuration on the adapter, which says install protocol.
Yes, right. So you can go to settings, network settings, and properties of your interface. Yeah, properties.
Is there a...
There is install, the left button, install.
And you select protocol, and you
Protocol.
select IPv6.
And you can, exactly. Okay.
Can we just do a trace route from the laptop as we did on Mikrotik?
Excuse me?
Okay.
Well, we cannot yet connect to the internet because my gateway does not know your network addresses.
There's something called temporarily IP version 6 address.
No, this is good. IP version 6 address. Oh, I don't know.
And temporary.
It is temporary. Well, I don't know why they did choose that address.
Should be this one.
Yeah, this one because it's based on your. Huh? Oh no, it's not based on your MAC address. Okay, you will see. Does everyone have IP version 6 address on his Ethernet interface? And if no, why and who? This means you have or you don't have?
Yes, I can.
Okay, so we have IP version 6 connectivity. So one last thing we need to do. Okay, simple question. Why did the IP packet die in the network? Because there was RIP in the network. So now we will use OSPF. Yeah, sorry for those who use RIP. But OSPF is better protocol, and we will use OSPF version 3. Well, if you have enabled our routing packages and IP version 6, in the routing menu we have such protocols as OSPF version 3 and RIP-NG, next generation. So these are protocols to route IP version 6 addresses. We will use OSPF version 3. So please, everyone, go to the routing menu and OSPF version 3. And first thing we need to do is to change the router ID. So we go to the instances and change the default instance. Is it already?
Yes, time.
So if we did that, we would have IP version 6 connection to the network. And if we go to this web page, we would see our IP version 6 global address seen from the network. So each of our hosts would have global IP version 6 address and IP version 6 connection. Sorry we didn't do that in time.
No, it's okay. Getting it all in time wasn't the part of the task.
Yeah.
Part of the task was prepare an interesting presentation. presentation. This
I-
was one of two interesting presentations we had.
I didn't expect so many questions. Really.
Okay.
And I
Sit
expected a
down.
few more hands with that already configured IPv6.
Sit down, take the paper, and let's start RouterOS.
Oh, okay. Right.
Okay, who wants to start first?
I need to rest.
Who wants to start first? Okay.
I think this was a very interesting presentation into diving into a world that I don't know much about. So, as this is the future, I'm glad you showed us this as an introduction.
Sorry?
Actually, you showed us a little view of a world that I don't know,
Yes.
which I need to know in a few months or years. So it was very clearly described. I think you have good slides and good live presentation. So I'll give you.
So no minuses.
No, I can't see immediately.
Okay.
Just want to give him a big applause. That's,
Also no minuses.
yes.
Anyone with minuses here?
I'm trying to think of something.
The problem that's because all we focus on the
All
new
the time.
subjects, so we forget what his mistake is.
He is focused on the time. No.
Yes, I
Come on, come on, come on.
presentation.
Time is running.
It looks like some of my methods finally work. No?
Yeah. Come on, come on. Guys.
Well, I would like to say a few things because I already planned before coming to Budapest to show the wireless and so on. I didn't manage to prepare a script pinging each one of you to see if there is everyone connected, but I would like also to add this to the presentation. We will see in the just a simple table whose host is pinging and who's not, and so on. These are not just your methods, because I
No.
I
I
also
mean
treat them.
that we discussed these 2 days. Common mistakes, how to present, and so on. So.
Yeah.
That-
Each day I changed a bit my slides.
Yeah.
That's true.
I want to ask him that it's the same slide when you come in Poland? I mean, from Poland to here?
I don't plan to use it in Poland because I don't
It's
know.
the same slide what you create at home?
Sorry?
It's a
Is
slide.
this the same presentation that you created at home?
At the start.
Or is it
And now.
completely different already?
Not completely different, not the same. It's a corrected version. I think 25 to 35% was corrected.
Okay. So, no minuses. Not the one.
Not the one from the class, so let's listen to you.
You cannot see anything when you hear.
I have empty paper, sorry. Also, no minuses from here. So, thank you.
Okay. Thank you very much.
10-15 minute break.